In this class, there's a lot of formulas we want you to use. Um, you do not need to memorize a lot of them, but I want to focus more on the techniques. So like more like a different method. So for section 1.7, is talking about integration in your result is going to be an inverse trig function. So for those kind of things, if you identify the pattern and you can directly using the formula. There's not really any techniques to use. So this section is going to be really quick. So in this section, section 1.7, we will have three formulas. So if I want to find the integral of du over square root of a squared minus u squared, so this is the format, then the end result is going to be the inverse for the sine function, arc sine, of u over the absolute value of a. If we have integral du over a squared plus u squared, then we have a tangent inverse function. And if we have du over u times square root of u squared minus a squared, then we will have the secant inverse. So let's looking at some of the examples we have here. So the first one, I want to find the integral of dx over square root of 4 minus 9x squared. So we can see that this one is very similar to the first formula, square root of a squared minus u squared. So that means 4 is going to be the a squared place, and 9x squared or 3x quantity squared is going to be the u squared. So u is going to be 3x. Then once we know those two, we just directly plug in into the formula. So this one is going to equals to sine inverse of the u over absolute value of a plus c, where u is 3x and a, which is 2. So the final answer is going to be sine inverse of 3x over 2 plus c. So you can see that there's not really too much to think about it. However, there is one thing I didn't solve at the beginning, which is because u is 3x, so du is equals to 3dx. Then dx is equal to 1/3 du. So there is actually a 1/3 in the front. Because of the u, we need to matching the du and the dx also. So here we're going to thinking about like a composition function or chain rule. So du is different than dx. So u is a function of x. So we do need to find what is du and then what is the relation between du and the dx. Now let's looking at another one. Next example we have is integral 1 over 1 plus 4x squared dx. Then this one is very similar to the a squared plus u squared format. So let's write the formula on the side. So if I have du of a squared plus u squared is equal to 1 over a tangent inverse of u over a plus c. So we can see that the a squared is corresponding to the 1, then a is going to be 1, or plus or minus 1. 4x squared is corresponding to u squared. That means u is going to be 2x. Now let's take the du, which is going to be 2 dx. So the dx is going to be 1/2 du. So let's apply the formula. So according to the formula, this is going to be integral of 1/a tangent inverse of u/a plus c. Now a is going to be 1, u is going to be 2x, and then the 1/2 we got it from taking the derivative of the du. Then combined everything, we got one. Oh, sorry, I shouldn't have this integral signs anymore. Then we got 1/2. 1/1 is just 1. Tangent inverse of 2x plus c. I try to do the color code so you know which number is coming from. Then the last example we have is integral of 1/9 plus x squared. It's kind of similar to, or we're using the same formula as the previous one. So a squared is corresponding to 9, which means a equal to 3. X squared is corresponding to u squared, so that means x is equal to u, or u equal to x. Then du is just equal to dx. Then according to the formula, it's going to be integral, oops, no more integrals. It's going to be 1/a tangent inverse of u/a plus c, where a is 3 and u is x. So the final answer is going to be 1/3 tangent inverse of x/3 plus c. We can see that there's not too much to talk about it in this section. If you know the formula, if you remember the formulas, you're able to identify what is the a, what is the u, and which formula to use. And that's pretty much it. The only part, pay attention to the du dx portions. You do need to treat them as the chain rule, as the additional derivative. You're going to take in the derivative of the du to match to the dx. So pretty much I need to replace this one with the du. And that's it for this section. We'll see you in the next one.